So today we'll be creating an SQL agent where we'll be giving some normal natural language query like give me the average salary for the employees, or give me few customers whose name starts with a letter P, or maybe a query where we need to join between multiple tables, right? So this kind of queries we can give in plain English, and the agent will create the SQL query. It will go and execute the query and give us the result. So we'll create this SQL agent with the help of LangGraph framework, and let's get started. So we are creating the SQL agent here. We are using one SQLite database. There is one existing database I'll be using. So our main agenda here is not to create one database, right? So we are just trying to use one existing database, and we'll see how to create the agent using LangGraph. So there is this database we already available. So we are accessing the database using this URL, and we are downloading the database. Then we are just connecting with SQLite Connect. Next, I will be displaying few data using pandas data frame, just to get some understanding about the database and what all tables we have and what kind of data we are storing in this database. So there are different tables, but few tables I'll be using here. First one is this artist table. I'm just selecting 5 rows from this table, and this is having artist ID and name. And then the next table is a playlist table. It's also having the playlist ID and the different playlist types, basically the music, movies, TV shows, etc. Next, we have a table called playlist track. That is basically a mapping table between a playlist type and the track ID. So this is the playlist ID and this is the track ID. And also we have a track table that is basically storing all the tracks. So this is the track ID, these are the track names, and the album ID, the genre and composer, and other details. So these are actually, we can consider these are actual tracks, and they belongs to some playlist, and there is some mapping between playlist and track. And also there is an artist table we already have seen. Next, I am trying to do some join between few tables. So playlist track, and track. So these 3 tables I am trying to join. Basically, I am trying to use some SQL query that will join between these 3 tables. So I am using this query like find few tracks from music playlist where composer details is available. Like you can see it in this way. Music playlist, so there are different types of playlist, right? So for this music playlist we are trying to find out the tracks. So we are just finding few tracks from music playlist where the composer, there are that a few entry, the few rows where composer details are not available. So I'm just trying to find out few tracks for music playlist where composer details are available. So there is this track, and this is the mapping we have between playlist and track. So this is doing a join between these 3 tables and giving the result. So these are the track names, these are the composer, and it belongs to playlist ID 1. Playlist ID 1 is, if you see, playlist ID 1 is music, right? And track ID also it is giving, but I think this select clauses we can change and play around with it. So this is just to uh, get some idea about what all tables we have, and we will be using this type of query using our agent. So here we are directly giving this SQL query, but instead of that we will just give some query like this English query, like find few tracks from music playlist where composer available and all this to the agent, and agent will directly create this type of query and it will run the query and it will just give us the details. So yeah, so first we'll be seeing the LangGraph SQL database tools. uh, we'll be installing LangGraph, LangGraph community and LangChain Anthropic. So I am using Anthropic as an LLM here. You can use anything you want. You can use OpenAI or you can use any Grok APIs as well, or any other APIs, Llama 3 and whatever you want to use, you can use. Now this is my LLM from LangChain Anthropic. I am just using this chat Anthropic model. Next, I want to access the tools, the SQL database tools LangChain community has, right? So it has a SQL database package. So that is to access the database. So this DB object we are getting, and we are just trying to access the database using this URI. So you already have downloaded the database that we are just trying to access. Next, I'm just printing the dialect. So dialect, of course, this is an SQLite database. Already we have seen and we have told about it. So this is, I'm just printing it. Then db.get usable table names. This is just to print the tables we have. So yeah, we have album table, artist. There are a few other tables like customer, employee, genre, invoice line, media type, and also this tables like playlist, playlist track and track. These tables we already have seen. Next, I am just selecting few data like top few 10 data from the artist table. So it is having the artist ID and the artist name. So if you have seen here, artist ID and the artist name, right? So yeah, that's it. So next we'll be actually accessing the toolkit. So that is having all the tools that is available in the LangChain. So this is the toolkit. There I am passing the database, or the database we have downloaded, this database basically, and the LLM, that is the chat Anthropic LLM we are passing, and we got the toolkit, and we'll see what all tools we have. So this is the tools we are using, toolkit.get tools to get the tools. Then I'm just printing the tools. So these are the tools we have, right? SQL DB query, this is to query the data, query the database to fetch the details. This would, if we give one SQL query to this, and it will actually go and execute that. We can use this tool, or also we can directly use this DB database we have here, right? We can use db.run, or you can use SQL DB query, this tool. Both we can use to actually execute the query. Next, we have a SQL DB schema tool that will give schema for a particular table. And next we have SQL DB list tables. So this is to list all the tables available in the database. Next we have SQL DB query checker. This is to check the query for anything wrong. All right, but we'll not be using here, we'll be using something different. But let's try to use these tools once to see how it gives the results. So first is list tables tool. I'm just accessing all the I'm just separating the tools here. So this is the SQL DB list tables. I'm just taking it in a list tables tool. This is the SQL DB schema table, that is in get schema tool, and this is SQL DB query, that is in DB query tool. Now list tables tools dot invoke, it is giving us all the table list. Next, get schema tool dot invoke artist. So I'm just asking this tool to give me the schema for this table artist. So this is the schema for this table. sorry, artist. It has artist ID, name, and its primary key is artist ID. Now, our next query is we are trying to use db query tool dot invoke, and this is the SQL query we are giving, and it is giving the result. So it's giving two. Sorry, not this one. Yeah. So actually, the db get schema tool returned this much, right? It gave this create table command and then a few examples, and then db query tool, when we execute it, we just used limit 2, so it is giving us 2 results. So this is 2 results, these are the 2 results. Now we saw the tools that we have, and we'll be using that tools, right? So first we'll be creating a fully autonomous agent where we'll be using LLM, and we'll bind all these tools we have with this LLM, and LLM will decide what to do with these tools. We'll just give some input like a simple message. If we pass like find two artists with names starting with A, so this kind of input message if we pass, the LLM will decide what to do with the tools, and ultimately it will give us the result. So how do we create such graph using LangGraph? So we are importing state graph start and end. To state graph is to create the builder for the graph. Then we have start and end to special entry and exit nodes. Then we have message state, this is to maintain the state for the graph. And then we have this tools condition and tool node. So tools condition actually decides whether to go to a tools node or not. This is a pre-built function, but we can use our own own this type of conditional function for our use cases, right? And this tool node is to create a tool node. If we have a function that we want to use as a tool, so we can use this tool node function. Or if we have a we have already existing few tools that we want to use, then also we need to use this tool node class. First of all, I am using creating the builder. Then I am creating this SQL assistant, which is taking the state as the message state, and uh, the message is it's returning llm.bind tools. It's binding all the tools we have with the LLM, and then it is invoking the message, right? So so if we just give this type of message, find two artists with names starting with A, LLM will try to answer this question. This SQL assistant will try to answer this question, and it has access to all the tools, right? So now if it decides to call a tool, next we need so first we needed node SQL assistant that we have added. Next we need a node tools, right? So if LLM decides to call a tool, we need a tools node. So here we have a tool node, and here also I am just passing all the tools. So these tools, I think you remember, here we collected all the tools. So these are the tools we have, right? So these tools we have, that we also created one tools node here. Now we want to add the ages. From start we want to go to SQL assistant, and from SQL assistant we have to go to the tools node, right? That is a conditional age. So we want to add one conditional age from SQL assistant based on the tools condition class. Sorry, based on the tools condition method we have. So this is a pre-built one we have imported from langgraph.prebuilt, and that will decide if in the previous node, in the SQL assistant node, if the LLM decides to call a tool, it will go to the tools call. Now if you see the graph from SQL assistant, it is going to tools, it can go to tools, or it can directly end. Now from the tools also we have one age to SQL assistant. Why do we need that? Because when we are passing one English this type of question or query, right? So it has, the LLM has access to all the tools, but it cannot directly answer the questions. It has to go through certain steps. First, it doesn't know about the database. It has to find out what all tables the database has, right? Then, using like the query we have passed, based on that query, the LLM has to decide which tables are relevant. So we have to create the query using those tables only. So that next step is LLMs has to select those tables. Next, after getting the tables, then we need to see the table schema. That for that also, LLM has to use some tools, right? So there is some get schema tool that we have to use. For the first time, for the first case of to get all the table details, it has to use the list tables tool, right? And then after that, LLM has to decide which tables make sense or relevant for this query provided, and then it will select the data tables. Then it has to use this get schema tool to get the schema of these tables. After it got the schema of this table, LLM can try creating some SQL query, right? After it creates an SQL query, then it has to use some other tool to actually go to the database to execute that query. For that, it can use this DB query tool. So there are different steps, right? So it cannot, this agent cannot do everything all at once. It has to go through multiple steps. So that's why we need this loop here. From tools node also, it has to go to SQL Assistant. So SQL Assistant, first we got the query like find two artists with names starting with A. SQL Assistant first will use the list tables tool, right? It will come in the tools node, and then tools node will give us the list of tables. It will again go back to SQL Assistant. SQL Assistant will decide which tables are relevant. Then it will go back to get schema tool. Get schema tool will decide, actually will return the schema of the tables selected. Then after that, again it will go back to SQL Assistant. SQL Assistant then yeah, SQL Assistant got the schema for the tables, right? And then it will generate some query. Then it will come again to tools like DB query tool that will do the execution. So there are separate like different steps that the agent needs to perform. And why it is a fully autonomous agent? Because the full control is given to this SQL Assistant. So we are not doing any manual steps here. We are not directly calling any tool here. Like we are just giving the full control to this SQL Assistant. So that's why it is kind of a autonomous agent. Now I will invoke the graph. Like we are using graph stream because we want to see the messages in chunks. Now we are passing this input message and we're just printing the result. Let's see what it returns. Okay, I think 1 second. Yeah, so it starts here. First we are passing the human message. Find two artists name starts with A. That is the human message we are passing in this input message. Now there is an AI message. It's returning to find two artists with names starting with letter A. We'll need to query the database. First, let's check which tables are available in the database, and then we'll look at the schema of the relevant tables before constructing our query. So let's start by listing the tables in the database. So it is using this SQLDB list tables tool. It's actually this in this AI message is basically this SQL Assistant is returning, and it is returning the tool call. Then we have a tool message because this SQLDB list tables tool was called. Then it is returning the list of tables available. Now AI message, because it went back to this SQL assistant, it is returning great. We can see that there is an artist table in the database. Now let's check the schema of this table. So it understood that among all these tables, only artist table makes sense for this input message passed, right? So next it is it understood that this is artist table is the one it needs, and then next tool call is SQL DB schema, right? So next we get again, it got back, it went to the tools node, and the tools node we got this SQL DB schema tool is called, and it is giving the schema of this artist table. After that, it again went back to SQL Assistant, and it is saying now that we have the schema, we can construct our query to find two artists with names starting with A. We'll use the like operator with the wildcard to match names starting with A and limit the results to 2, right? And it is query. It generated one query SQL select artist ID name from artist where name like a percentile and limit 2, and this it is passing to this SQL DB query checker to check. So then again it came back to tool node, and this is the query checker. It is saying like this original query appears to be correct and doesn't contain any of the common mistakes mentioned. So here is the reproduced query. So the query checker checks for any mistakes in the query, and it is reproducing the query. If any mistakes are there, it will reproduce, otherwise it will return the original query. So next we again went back to SQL assistant, and it is returning okay, none. Now the query checker confirms that our query is correct. Now let's execute the query, and it will execute the query. But how? It will use the SQL DB query tool, right? And with the query, right? So the DB query tool, then it will come to this tool message, it will execute the query, and it will give us the result. Then again it going back to SQL message, and that is printing our data in some format, right? Great, we have successfully found two artists with names starting with A. Here are the results, right? Artist ID name this, artist ID name this. So now we can just print this final message as well, but I have just printed all the messages here. Like I'm just streaming and I'm just printing all the messages here just to understand the flow. Now let's say I'm passing it like normal, like some other message like hello, how are you doing. So if we pass the message, that of course the assistant will decide that of course it doesn't look like a SQL query at all, right? It will just directly return like I'm doing well, thank you for asking, as an AI assistant I'm here to help you with any question or whatever. So it is not actually performing the query. So because the way we have handled it, right, SQL assistant can go to tools call and also it can directly end. So it's returning some update and it is ending. Now one problem we have with this autonomous agent is we are giving so much of control to this LLM, right? And there will be some time, right? If you keep experimenting with different types of queries and different LLMs also, then you will see the LLM will hallucinate, and it will not, sometimes it will not call the exact tool, and it will create some wrong query, or it will ask, right? So so we'll not create a fully autonomous agent here. We'll call something less autonomous. Let's see how we will rewrite the agent with tools control. Basically what we'll do is uh, we'll call few tools on our own, right? So suppose first call is we have to list down the tables. We need to know what all tables we have. So that is a tool call, that is a must, right? So we don't need to rely on, we need to rely on the LLM to give like take that decision, right? And also one more benefit we have here, So we are not unnecessarily calling the LLMs, right? So we are directly calling the LLM, we're directly calling the tools, and whenever just needed, then only we are just calling the LLM, right? So so I'll be defining few tools here, then we'll just see how the graph is created. So we'll create this type of graph here. I'm just showing the graph beforehand so that we'll have some idea like what we are going to create. So first we have the SQL assistant, and then we have a list tables tool. This is the tool that we'll be calling. And then we have a model get schema, that is to get the schema for the tables. Then we have a get schema tool. Sorry, after list tables tool, model get schema, this is an LLM call only. It decides what all tables are relevant and asks for the schema for that, for those tables. Then after that we'll call the get schema tool to call to get the schema of those tables. Then we have a model generate query that will actually create the query. So here whatever nodes are ending with tool, right, list tables tools, get schema tools, these are actually tool, right? Here we have execute query tool. So these are tool. And like this is an LLM call, and this model get schema, this is a model call. This is a model is taking some decisions. And then model generate query, this model is generating some query, right? And after model is generating the query, we have a different node that is to check whether the query is correct or not. This is a model correct query node. So after generating the query, it will go to model correct query. But if it decides this in this node model correct query, if it finds out that the query is perfect, then it goes to execute query tool, right? So execute query tool, this is the tool call. It will execute the query, and then from here also it can go to again model generate query. Because like after executing the query, if we don't get any result, or if you see the result is not good and all, so I mean basically if you get not, if you don't get any result, then we'll go back to model generate query again to generate the query. Like there is something wrong with the query, model correct query checked for some syntactical error, but even in that case also we are not sure if the query actually didn't produce anything. So again we'll go back to model generate query. And model generate query also has some loop here, like it is see this loop here. So model generate query, this here model will generate some query, and then again it will check whether the query is fine or not. Then again it can loop back to this model generate query. But after all this, after if this successful, so after execute query, it's not always that if the result is empty, then only it will go to model generate query. If it is getting a result, then if it is going to model generate query, then also model generate query will see that okay, the query is generated, it can directly end. So this is the type of flow we have created here, but you can modify, you can create your own type of flow, you can just do some modification. Okay, let's start. So one tool we have is DB query tool. So this is the last one, execute query tool. Here we have seen we have this SQL DB query tool available right from this toolkit. We can use that. Otherwise, I'm just creating one DB query tool. Here I'm using this db.run no throw with the query. This query is passed, right? And this I'm just testing it. What is this DB? If you remember, this the DB. We got the connection, we got the here, where is it here? So here from LangChain community SQL database, here we created the DB from this SQL database. So we can use this db dot run no throw with this to actually execute the query. Next we have few, we will be creating the model like model calls, like LLM calls we have, right? So we have one model get schema, we have this SQL assistant, and then we have model generate query, model correct query. So we'll be creating those nodes here. For those nodes, we have these functions: uh, SQL assistant, model get schema, model generate query. But before that, we are generating this builder, and this is the LLM.bind tools. This is LLM with tools. We can use this way, or I prefer trying to use this way. Like whenever we'll be calling, right, LLM, and instead of using LLM with tools, this one initially using with here, I just try to bind it before calling. So we don't, there can be less mistakes, right? Unnecessarily we won't bind any tool that is not needed. Right, okay. So this SQL assistant, it will just invoke the message, whatever message will be passing, it will just invoke that on that message. Model get schema, it's a model call, it's just to get the model schema, right? Here I'm just in the model get schema, I'm not trying to bind it with any other unnecessary tool. I'm just binding it with get schema tool, because that is needed in this, right? And I am invoking the message. Then we have model generate query. So this is basically one prompt I'm using. You're an SQL expert with a strong attention to details. Given an input question, output a syntactically correct SQLite query to run. Never output a tool call or tool result, whatever, strictly follow this. We'll see why we don't need this tool call, but yeah, when generating the query, unless the user specifies a specific number of examples they wish to obtain, always limit your query to at most 5 results, right? Always, if by default it will give 5 results. You can order the results by a relevant column to return the most interesting examples in the database. Never query for all the columns from a specific table, only ask for the relevant columns given the question. So these are few instructions we are giving to the model to generate query. So never make stuff up if you don't have enough information to answer the query. Just say you don't have enough information. Do not make any DML statement like data manipulation, data like the statements like insert, update, delete, or drop, etc. to this database. And never output a tool call or tool result. So it's actually why don't we want any tool call? Is basically this node is supposed to generate the query. It's not supposed to generate any tool call, right? So this basically you just want this node to generate a query so that we can go to the next node where we'll be checking for mistakes in the generated query. Next, I'm just trying to bind this tools with get schema tool. So why I'm binding with get schema tool is the input we are getting in this model gen query is from this one model get schema. So there is some dependency here. We need to bind it with get schema tool because the input is coming from the get schema. So otherwise, we don't need any other tools in this node. I mean, this is the function for the node. We have not created any node yet, but this function will be used to create the node. Next, we're just calling this with the messages we'll be getting in this layer. Next, we have a model correct query. That is here we are passing one prompt like you are a SQL expert with strong attention to details. Double check the SQLite query for common mistakes, including using not in with null values, using union when union all, and this are some specific like SQL syntactical uh, uh, guidelines we are providing to the model so that it will check for this type of errors, like using between for exclusive ranges, data type mismatch and predicates and all this, casting to the correct data type, using the proper columns for joins, using the correct number of arguments for functions and all this. So if there are any of the above mistakes, then rewrite the query. If there are no mistakes, just reproduce the original query. I will strictly call the execute query tool to execute the query after running this check. So there is some execute query tool. Where is this execute query tool? Okay, we have not called created it, but we are just strictly telling is this call this execute query tool after you have generated one correct query. Next we are just calling it, and here in this layer I am binding the LLM with db query tool. What is this db query tool? Db query tool, this is the one. I think the model will understand, instead of the execute query tool, we can call it as db query tool, right? So after generating the query, regenerating the query, it will call the db query tool. Fine. Now correct query tool condition. Okay. So this correct query tool condition, we'll see how it is. But now here we are generating the nodes. First we have this SQL Assistant node. Then we have this list tables tool. Here in the tool node, I'm just creating a tool node with list tables tool, because in this node we don't need any other tool. So I'm just trying to keep it very simple. Now we have this model get schema. So this the model get schema function we created here, right? Model get schema, that is to grade the schemas. So that is we are using here. After getting the schema here, we are creating a tool called get schema tool, and here we are passing creating a node, tool node, with just the get schema tool. After that we have model generate query. That's the generate query function we already created here, right? So we are just creating a model node from here. After that we have this model correct query. So this is the correct query that we have created. We created that node. And then we have execute query tool, right? Execute query tool we have, and that there we are just creating a tool node with db query tool. So I think I made some mistake here. We should not be having this I just changed it to db query tool, right? But it should be execute query tool only, because the query, the node we have named as execute query. But yeah, so after that we are creating the ages. So from the start we'll be going to SQL Assistant. From SQL Assistant we'll be going to list tables. From list tables we'll be going to model get schema. Model will decide what all tables are relevant, and will uh, ask for schemas for those tables, and it will create a tool called like this get schema tool. So model get schema, from model get schema, one get schema tool will be called. So after get schema tool, after we got the schema, then we have this model generate query. So from model generate query, we have one conditional age, right? So model generate query, for model gen query we can go to different nodes based on some condition. So that condition we have written here, correct query tool condition. So how it is deciding, see the condition here. Model generate query, from model generate query we can go to model correct query, we can end it, and also we can go to model generate query again, right? When we want to regenerate the query, we'll go to model generate query again. When we want to, we have produced some SQL query, we want to go back to, sorry, we want to go to model correct query, then only we'll go to model correct query, otherwise we'll end. So we'll see the condition. This is the condition we have written, and this is the condition we saw earlier. Now we'll see how it is working. So how it is this it's taking the message state, and it can return all this three, right? It can either go to end, or it can go to model gen query itself, starting from model gen query to again to model gen query. It's a self loop. And then it also it can go to model correct query. So how we'll decide? We'll get the last message, and if last message content is empty, like basically we have executed the query and then we have don't have anything, then we'll end. And otherwise, if we have the last message content is present and last message content starts with error, like when it is error, so where were we? Okay, so there are two possibilities, like okay, so when it has to go to model generate query again, so there are two conditions, right? Last message that content starts with error, when it will run, when it will get error, right? So if you see here, when we are running this db query tool, there we are returning some error function, like error, like if we are not getting any result, if it is an empty result, then we are returning this error. So if we are getting this error, right, if we are getting this error, then we'll return model generate query again, because we want to rewrite the query, right? And else model else will go to model correct query. So if we get some error after executing the query, after executing the query, if we don't get any result, then we'll get this error from this db query tool, and then we'll again go back to model generate query, and we'll regenerate some other query, and then again after generating it, and again it will go to model correct query. But for now, at this moment, if we get any error, it will again self loop to model generate query and regenerate some other query. So this is the condition, but otherwise it is going to model correct query because it has generated some query. So after that, we got into model correct query, right? So if correct query, what it will do, it will check the here is the model correct query code. So it will check for basic mistakes and all, and if it satisfies, then it will go to execute query. So for model correct query, we have an edge to execute query. After execute query tool, we are going to model generate query. So there is an edge from execute query tool to model gen query as well. So this tool I am talking about, it's just like for this type of scenarios, if the model execute query doesn't return any result, right, it will again go back to model generate query. So that's it, this is simple. So we'll compile the graph, and this is the graph, I already have shown the graph image. And now let's start and execute the query. Let's see how it is, and we're just printing the messages we are getting. It's simple. The same calls only earlier we saw for the autonomous agent. The calls will be similar, but in this agent we have more control. But that we are giving less control to the LLM, and we are also restricting the LLM calls and tool calls. So it is more reliable in some sense, right? So we have this human message, then we have this AI message. To find query data, we need to query the database, and then we're calling this list tables tool. So we are only calling this tool message. And then AI message, we got the AI test table, then it is the tool call is SQL DB schema, and it is calling the schema. And next we got the SQL query, right? So it's giving some explanation, we don't need that, like this just generating the query and giving some explanation. So this is the LLM is doing all this. Then we have one more AI message. Why we have, so this AI message, this is coming, sorry, this AI message is coming from model gen query, which is first generating the query. Next, the next AI message is from model correct query. So it's let's execute this query using db query tool because it could not find any mistakes in the query, so it's just calling the db query tool. So next tool call is db query tool, and this is the db query tool and it is returning some result. Next it went to a message again and we got the and next we got the it went to AI message again and it is returning the result. So fine, next try some other query. So next we have this input message, name few tracks composed by F Baltis. So what it will do, it will go check in the tracks table and will look for tracks which is composed by Baltis table. If you just see the track table once, yeah, so this is the track table. We have few tracks and there is a composer column where we have the composer. So if you see there is this composer, basically I am trying to look at, we should get this few names. I mean there can be other rows, only I am displaying 5 rows here. There can be other rows as well, but we'll get some tracks where this composer has composed for this for those tracks, right? Let's go there. Yes, so this is the one. Yes, so this is the one. So I'm just printing the result here. Messages here and yeah, so this is the human message. And similarly it's just querying the database and it found it got the list of tables and it found that the track table is relevant for this query, and then it's getting the track schema. So this is the track table schema, and then it's generating some queries. We'll select name composer from track where composer like the safe buttons, right? And then what it is calling the SQL DB query tool, and it is querying the table, right? And then it is returning a few tracks here. You see, first as a sharp, 5 baltas and all this, right? So and then it is printing the result based on the query result. Here are a few tracks composed by baltas, like first as a sharp, composed by Fueltes, and it's just producing like reproducing the content, the message in a more formatted way at the last stage. Now last we'll be seeing one join query, like the join query initially we talked about, right? We want to find few tracks from music playlist where composer details available. So like we are, there is a playlist table where we have a few playlist types like music, movies and all this. We want there is a track table where we have the track details and the track names, composer and whatever, and there is a mapping table called playlist track, which is having the mapping between playlist and track. So we need a few tracks for the music type, right? Music playlist. So we have to do some join between these three tables. So let's print the result and I'll see how it, I just call the message and this is the result. So first it's just getting the tables, then great, we can see that there are several tables related to music including playlist, playlist track and track. So it understood, the model understood that for this query it needs to query these three tables, right? So next, using the db schema table and this db schema tool, it is trying to get the schema for all the tables. So you see it collected, this is the playlist schema, this is the playlist track schema and this is the track schema. So this three schema it found, right? After that there next it is, and it went to model gen query node, right? And we can create an SQL query to find tracks from the music playlist where composer is available. So it created one query like this. Select t.track id, t.name as track name, t.composer from playlist P. Join playlist track pt on p.playlist id is equals to pt.playlist id. Join track t on p.track pt.track id is t.track id, where p.name is music because playlist name is music, t.composer is not null, and t.composer not equals to none. This has to check if this is syntactically correct or not, and right, but let's see what it results. uh, it called the div query tool with this, and of course it was successful. The tool message we got that these are the tracks, music tracks with some composer details. So it got the track ID and track name is this and composer is this on it. Whatever, it got us some result, and yep. So we saw we first saw the SQL schema, and then we saw the tables in it, and we just went through few tables and saw the data in there, and then we saw the SQL tools available in the LangChain or LangGraph, and then after that we created one autonomous agent, and we saw how it is working, and we saw the pros and cons of this autonomous agent, and then we rewrote the agent with some more control, some more human control, right? With some more model, like controlled model calls as well, right? And then we ran the agent with few different queries. First few simple queries, that one selected few artist from artist table, and the next one selected few tracks from the track table if I'm not wrong, and then we tried one complex join query as well. That also we got result from this join query. So agent created the SQL query, executed it, and gave the result back. So yeah, thank you.